let's analyze one more amplifier circuit. And in this case, we now starting connecting two transistors together. In this case, we have an NPN transistor connected with a PNP transistor. And when we start doing these multi-stage configurations, it's important to start recognizing configurations, single configurations. For example, this one that we have over here, it's similar to the exercise number 3 that we did. And we have exactly the same resistors in the emitter and collector in here to bias the transistor. That means that the values are pretty much going to be the same in terms of current and voltages, but the only difference is going to be at this VC1. This VC1 is now going to be different because this VC1 is equal to VB2, and we have this PNP injecting a little bit of current here in this circuit. So let's analyze the circuit by doing our hand calculations. All right, so let's go and start by designing our circuit. This is just a good practice. In this case, we don't need to change the way that the circuit looks, but sometimes redesigning helps us identifying features or components in the circuit that might not be obvious when you have the circuit in that configuration. And I'm going to also populate the schematic with the information that it's going to be relevant for us. So values of resistors and power supplies. I'm also going to include the voltage VBE and VEB. They are the same for this analysis, equal to 0.7 volts. And my beta equals to, my current gain equals to 100 for both transistors. All right, so let's write those values for that first transistor that we calculated on exercise number 3. So EB1 and the current flowing through the emitter 1. So I wrote 2 over there, and I'll fix it in a minute. So the current through the base is 12.79 micro, and the current flowing through the emitter 1 is going to be equal to 1.29 milliamps. All right, we're going to also write IC1. Notice that IC1 is that current now over there, not the current that flows through the 5K. And we get 1.277 milliamps. And I'm going to also write the two voltages that are similar to exercise number 3, VB1 and VE1. All right, so knowing this, now I'm going to try to find that current over there. So I'm going to apply KCL on that node, and I have 3 currents involved on that node over there. And I can write the following equation. So the current I is going to be equal to IC1 minus IB2. All right, so if I apply Ohm's law, before I even do that, let me just write these equivalents here, that VC1 is going to be equal to VB2. It will help us later on our analysis. And now let's apply Ohm's law on that 5K, and we see that we have 15 volts minus VC1 is going to be equal to your 5K times that current I. I'm going to rearrange this equation in terms of VC1, and I'm going to have the following result. And now I'm going to substitute that I by IC1 and IB2. And I'm going to have one equation with 2 unknowns. So that means that somehow I need to analyze the circuit in order to get a second equation that relates VC1 with IB2, so I can find those values. And that can be found by looking at the PNP transistor and try to find a relationship between the emitter current and the voltage at the emitter on the PNP. If I apply Ohm's law on that part over there, I have 15 minus V2 is going to be equal to the current times the resistance. All right, what else do I know? I assume that the transistors are in active mode, so IE2 is equal to beta plus 1 IB2, and that V2, I can also get that by the relationship between VEB. So VEB is VE2 minus VB2. And if I rearrange this equation, I get my VE2 in terms of VB2. Alright, this is good news, because now if I put all of that on that first equation, so 15 minus VEB minus VB2 is going to be equal to my beta plus 1 times 2K IB2. And notice now that I have my second equation. So this is my first in terms of VC1 and IB2. And this is my second equation also in terms of VC1 and IB2. And I'm just going to write down the values that we know. So we know VB is 0.7. We know beta plus 1 is 101. And we also know that VB2 is equal to VC1. So we can visualize those two equations, two unknowns. All right, so now you manipulate these equations back and forth. I'm going to just show the final result. And you get your IB2 equal to 27.46 microamps and VC1, which is equal to your VB2 of 8.75 volts. All right, knowing IB2, I can go and find IE2. And now that I know also VB2, I can find VE2. And the only thing that it's missing now is the current that flows through the collector of the PNP. And the relationship between the collector and the emitter is the following equation. And applying Ohm's law over the 2.7K resistor, I can find VC2 of 7.4 volts. All right, I'm going to highlight my answers. Again, this is just good practice if you are turning in a similar exercise for homework. Just makes it easier for the grader to see what your answers are. All right, we put all that information here. So we have the currents and the voltages for our NPN transistor and the currents and the voltages for our PNP transistor. And both are working in this active mode. And I put here in orange that VC1 is equal to VB2. And let's now simulate this circuit and see if we get values closer to these ones. I'm going to start with false start. I already have the circuit here designed, and I'm going to incorporate some test points. I'm going to measure the voltages, so VB2 and VC1. I'm going also to measure VE2 and VC2. Let's measure also VE1 and VB1. I'm not going to measure all the currents in the circuit. I'm just going to measure a couple. So I'm going to put an ammeter. I'm going to measure that current that flows through the base of the second transistor and my IC1. And my values are very close to the theoretical ones. Remember that VBEs are different. That's why we don't have exactly the same values. I'm going also to incorporate here the current at that Q1. Let me just shift things around so we can see that 13, that number 1. All right, pretty cool. So now let's go over the same circuit but in multi-sim. Same thing, I already have everything here ready to see the values. We get slightly different results because the VBE and VEB are different from the theoretical analysis.